Hello my dear students. I hope you all are hale and hearty. You have enjoyed your summer breaks. Now be ready to study and work hard. We will start with calculus, the new topic. This topic will be of 35 marks in your syllabus. And I will start with continuity. I have divided this continuity exercise in small videos that will be easy to understand and to complete your exercise. So today I will start this continuity. Continuity, the word. Let us try to understand the word continuity. For that, try to recollect the word limits of class 11. Class 11, you have already studied limits. You know how to calculate limits, what kind of functions exist and what kind of functions does not exist. You know to find the domain and range of particular functions. And one more word you know, left hand limit and right hand limit. The same concept I will use over here to understand this continuity. So to understand better, I have made these 4 different graphs for you. Let us understand this first graph. This graph, this is continuous, no jump, and when I come to x is equal to 2, here is a jump. Here is a jump, and after this, again this graph goes very smoothly. If here is a jump, it means I cannot find the value of this function exactly at x is equal to 2. And I can find the value of this function at limit x tends to 2 minus. 2 minus means left hand limit. I can calculate the left hand limit of this function, and I can calculate at the same point I can calculate the right hand limit of this function. Both these I can calculate, but I cannot calculate limit of this function. I cannot calculate limit x tends to 2 fx. This I am unable to calculate because what is there? At x is equal to 2, here is a jump. Now when I come to the second graph, in this second graph, this graph goes very smoothly up to infinity. Limit x tends to 2. If I write limit x tends to 2 fx, again not defined, I cannot write it. And when I come to x tends to its left hand limit, x tends to 2 minus fx, I can write its value. At x is equal to 2, it goes to infinity, and x is equal to 2 minus a small left hand limit I can calculate, and similarly I can calculate its right hand limit also. So what is this? This is this at x is equal to 2, this graph goes to infinity, and left hand limit and right hand limit both I can calculate. Now if I switch over to the third graph, let us see this third graph. This graph goes very smoothly, no gap, and at x is equal to 2 also I can calculate because here is no jump. No jump is there, anywhere there is no jump. This is very smooth graph. Without lifting my hand, I can draw this graph. So I can calculate limit x tends to 2 fx because it is here, it exists. Limit x tends to 2 minus fx. Again, a little left side, I can calculate its value, and if I go to right side, similarly I can calculate the value of this function right hand side also. Now, if I go to the fourth function, fourth graph, the fourth graph at x is equal to 2, I can calculate x is equal to 2, and I can also calculate limit x is 2 minus fx, left hand limit, right hand limit also I can calculate. Right hand limit also I can calculate. But I know these two, left hand limit and right hand limit, are very small point, left side to 2 and right side to 2, the values are different. The value of y, suppose it is 1 here, then it is here 5. So values of f are different for left hand limit and right hand limit. Now try to understand this continuity. Which function is continuous? The function, here is a jump, here is not a jump, but this goes to infinity, which is not defined to us, and we cannot do any kind of calculations with this infinity. And if I go to the third graph, without lifting my hand, very smoothly I can draw this graph. And this fourth graph, so this graph also is continuous, but it is discontinuous over here, because at x is equal to 2 minus, that is left hand limit, and the right hand limit of this function is different. So this is also not continuous. The third graph is only continuous. So continuity means if we can draw any graph without lifting our hand, then that function is called continuous. Let us move further. Talk about point continuity. Point continuity, the first graph, look at this. This function y is equal to x is continuous at x is equal to a, provided limit x tends to a minus, this is called the left hand limit, is equal to limit x tends to a plus, this is called a right hand limit, and limit x tends to a of x, this is limit of the function, value of the function at x is equal to a. If these all three are equal at x is equal to a, then this function is continuous at point x is equal to a. This is called point continuity. And if any function, let us move for the second graph. If any function is continuous at every point from a to b, this one, if this is continuous at every point within its domain from a to b, then this function is called continuous from a to b. Like, see, what if I can draw a graph of any function from a to b without lifting my hand? This is called interval continuity. Now, if I take the problem based on this point continuity, I have written if x is equal to mod x upon x, x is not equal to 0, and this is equal to 1, x is equal to 0. Discuss the continuity at x is equal to 0. What I have to do for this? At x is equal to 0, I have to calculate here. Means what I have to do? I have to find left hand limit. Limit x tends to 0 minus f x. This is equal to, this must be equal to limit x tends to 0 plus f x, and the same must be equal to limit x tends to 0 f x. Now see what I am given. For these two cases, x is not equal to 0. जब x is equal to 0 नहीं है, इसका मतलब x क्या है? या तो 0 माइनस है या 0 प्लस है. तो लेफ्ट हैंड लिमिट और राइट हैंड लिमिट दोनों को कैलकुलेट करने के लिए व्हाट डू आई हैव? मेरे पास क्या है? fx इज इक्वल टू मॉड x अपॉन x है, और जब x इज इक्वल टू 0 है, x इज इक्वल टू 0 है, तो fx इज इक्वल टू कितना है? 1 है. इट इज गिवन here. ये हम देख सकते. नाउ लेट मी कैलकुलेट इट्स लेफ्ट हैंड लिमिट. एज आई सेड, if I write limit x tends to 0 minus x, this is equal to limit x tends to 0 minus h, and h tends to 0. I will write mod x upon x. This is limit h tends to 0, mod of 0 minus h upon 0 minus h. What is this? Mod of minus h upon minus h. This will become h upon minus h. Hence this is minus 1. Left hand limit is minus 1. Let us calculate right hand limit. Limit x tends to 0 plus, I will write fx, this is equal to limit x tends to 0 plus h, h tends to 0. I will write mod of 0 plus h upon h. This will become h upon h. This will become 1. Alright, left hand limit is 1, and limit of the function. Limit of the function, limit x tends to 0 fx is equal to 1. I am already given. This is given to me. X tends to 0. Now look at this. the function is this? Right hand limit is 1 and left hand limit is -1. So this function is not continuous if x is equal to 0. Let us look at another problem.